Good morning, all. Myself, Dr. Beena Bundela, Department of Mathematics, JCRC University. Today, I am present my seminar, Analysis on a Resource-Based Population Model with the Capital Fractional Derivatives. These are the contents: Introduction, Mathematical Model, Boundedness and Equilibrium Points, Boundedness of the System, Dynamic Behavior of the System, Numerical Simulation, Conclusion, and references. The introduction. We suggest a new mathematical model for the effect of population on a resource-dependent native population. It is assumed in the model that both native species and exotic species feed on the same resource. This problem aims at developing a novel mathematical model in the sense of capital fractional derivative, which have remarkable result in actual life as both type of species feed on the same resource. In this model, we study existence, uniqueness, and boundedness of the solution. Also, the model analyzed stability theory, nonlinear stability of the interior equilibrium points. Here we solved with the help of Lyapunov direct method. Next, the numerical simulation results related to the stability is carried out. Now here we define the mathematical model, the capital fractional derivative of order alpha. C d alpha t r equal to r1 minus cap r upon k minus a1 n1 r minus a2 r1 star n2. C d alpha t n1 equal to a1 epsilon 1 r minus m1 minus b1 n1 into n1. Here the parameters is this: r is the intrinsic rate, k is the carrying capacity, a1 a2 is the per capita, b1 b2 intraspecific per rate. Now we discuss the equilibrium points and boundedness. In system also find some equilibrium points as the integer system given by Kushwaha. First equilibrium point E naught. Here the resource and species are 0, 0, not present. Axial is equilibrium point E1 K, 0, 0. The absence of E2 R is 0 and 2, where R has value is this and N2 value is A2 epsilon 1 K minus M2 upon B2. E3 exists if condition exists this condition B2R to then A4 A2 K square into A2 epsilon 2 K minus M2, and A2 epsilon K is greater than M2. And the fourth equilibrium point, boundary equilibrium point, R star, N1 star, N2 star, where N2 star value is 0 and the R1 is R star value is K A1 M1 plus B1R upon A1 square epsilon 1 K plus B1 into R. And the here we display the N1 star value. Now, existence and uniqueness condition. In order to prove that the solution for system exists and is distinct, we must first show that the mapping of G of M equal to G1M, G2M and G3M satisfies the elliptic condition in the area of interval 0 to infinite 5 with respect to M equal to R N1 N2. This is the condition for existence. We denote M bar equal to R bar N1 R N2 bar. Any M comma M bar belongs to phi. It follows that mod of G minus G of M minus G of M bar equal to this condition. Now We discuss the dynamical behavior of the system, given system in mathematical model. We will now study dynamical behavior. Equation 1 about the 5 feasible equilibria. First equilibrium point E1 is unstable, and the second E2 is linearly asymptotic stable if the condition is this: A1 epsilon 1 K1 is less than M1 and A2 epsilon 2 K less than M2 are satisfied. Now the third equilibrium point, linearly asymptotically stable. If the condition is this: A1 epsilon 1 R star less than M1, then now the linear asymptotically stable results solved with the help of Jacobian matrix. Here we represent the numerical simulations, a relation where our resource, native and exotic species to the specified under the capital fractional derivative operator. The first graph is represent the relation between resource and native species, where the value alpha equal to 1. Next, the second graph is represent the relation between three variables: resource, native and exotic species, with the value alpha at alpha equal to 1. Now the conclusion: with the aid of EBF, the relevant derivative was taken in the capital sense and we came up with the some suitable conditions for the existence and the individuality of equilibrium points to the resource-based native population model with fractional order derivative. If the death rate is lower than the rate of generation, however, if the stability of E3 were to be reversed, the local population would continue to exist while the alien population would go extinct. The existence of resource and both species has been inferred from the stability of the positive point. However, the equilibrium resource densities are further by the presence of exotic species. Following that, we represent the numerical simulation using AVM. Through simulation, we came out order system exhibit more complex dynamic. That these are the references. Thank you.